Number 7, the math club sells candy bars and drinks during football games. 60 candy bars and 110 drinks will sell for $2.65, and 120 candy bars and 90 drinks will sell for $2.70. How much does each candy bar sell for? And that's what we're looking for, and it wants it in dollars and then cents. So since we have two relationships here with candy bars and drinks and their totals, we can write two different equations in standard form. So our unknown is going to be how many candy bars, and how many drinks, and how many drinks, because we know the totals. So my first thing is to define what my variables are. So C is going to be my candy bar, and that's going to be the cost of the candy bar, and D is going to be the cost of the drink. Alright, so for the first equation it would be 60C, and means we're adding those because you're purchasing both of them, so plus 110D, and then it sells for $2.65, so I'll set that equal to $2.65. So we did the first one. The second one is 120 candy bars, so 120C because we don't know how much they cost, plus 90 drinks, so 90D equals 270. And this one is in standard form, so it's not easy to solve for C or for D. We have to do a two-step equation to do that. That is obviously an option, but I think the quickest way on this one is going to be elimination. Okay, so for elimination, the way we set up elimination is we try to get rid of one of those variables, and an easy way is just to see if one of the variables will go into, one of the coefficients of the variable will go into the other. So look at 60 and 120. 60 will go evenly into 120, so right away we know C is what we want to cancel. Look at 110 and 90. They're not going to cancel as easily. We'd have to multiply them both by something to get them to have the same amount. Whereas here, and you would do that using the least common multiple. But this one's a little easier because the least common multiple of 60 and 120 is just 120. So you only have to change that top one. So if we double that top one, it would give us, I'm going to write it above here. If we double that, it would be 120C. I'm going to double everything, so I'm distributing that 2. And then 2 times 110D would be a positive 220D. And then if I multiply the 2 by 265, that would equal 530. Now we can ignore that middle equation now because we've just converted it, and we're just looking at the top one, the 120C, and the bottom 120C. And how can we get rid of 120C? If we add them, it's going to give us 240, so we don't want to do addition, we want to do subtraction. And if we're doing subtraction, that means we're going to subtract everything. So think of it as 120 minus 120, and that cancels. And then 220D minus 90. So 220 minus 90 is going to give us 130D. And then 530 minus the 270 is going to give us a total of 260. And then it's just a one-step equation from there. So divide both sides by 130, and you have solved for D, because D is just going to be 26 divided by 13 is 2. Now that we have solved for the cost of the drinks, and by the way, that would be $2. Remember, our answer is in dollars. $2 for the drink. We need to find out how much it is for the candy bar. So we can plug it into any one of these three equations that we want to pick. I'm just going to pick the bottom equation. You could have picked any one of those three. So just pick the one that looks easier to you. So 120C plus 90, instead of putting D, I know what D is. D is 2. So I'm just going to substitute it in. So 90 times 2. And my total is still going to be the same. It's still going to be 270. So all I did was rewrite that bottom equation here and plugged in a 2 for D. And now I'm going to solve it. So 90 times 2 gives us 180. And 120C plus 180 equals 270. Now it's just a two-step equation. So I'm going to subtract 180 from both sides. And that's going to leave me with 120C equal to 90. And then I'm going to divide by 120 to solve for C. And I can divide that out, and it would give me a decimal 0.75, but I know 9/12 reduces to 3/4, and I know 3/4 of a dollar is 75 cents. So C would just be $0.75 or 75 cents. And since we didn't have a calculator here, this was inactive, you do need to reduce them like I did. So 9/12 is 3/4, 3/4 is 0.75. Yep. All right, so candy bars are 75 cents and drinks are $2. And that should work for both of these equations that we've written. Okay, number 8 says, what is the smallest of 3 consecutive positive integers if the product of the smaller 2 integers is 5 less than 5 times the largest integer? So I'm just underlining some key words here. Consecutive means in a row or right next to each other. Product means multiply. Is means equals. Less than means we're subtracting from something. And then of course times means multiply. So I'm going to try to write an equation here, but I have several unknowns. It says 3 consecutive positive integers. Well, I don't know what any of those are. So I'm going to call my first one as x, the first integer. And then the first one needs to be in relation to the second one needs to be in relation to the first one. So think about, I'm just going to write an example, 1, 2, 3. Those are consecutive because they're one after the other, integers, and they're all positive. So if I called that first one x, how is that second one in relation to the first one? It's 1 more, so x plus 1. How's the third one in relation to the first one? It's 2 more. So my 3 unknowns are x, x plus 1, x plus 2, and now really I only have one unknown, which is one variable, which is x. So x plus 1, x plus 2 is my second and my third. Alright, and it says the smallest, so which one's our smallest here? Well, that would be our first one, the one we're not adding to. So I'm going to take that. It says the product of the smaller 2 integers, well that's the next smallest one. So x times x plus 1. And then is means equals 5 less than 5 times the largest. Which one's our largest? X plus 2, because we're adding 2 to it rather than just 1. So I'm going to write x plus 2 here, and it said 5 times that, and then it's 5 less than. Remember, less than is almost backwards. You're taking 5 from that number, so I need to put the subtraction at the end there. And now we just need to use the distributive property and solve this out. So x times x is x squared. X times 1 is positive x. 5 times x is 5x. 5 times 2 is positive 10. And then I'm going to bring down my minus 5. I'm going to combine my like terms. So that would be 5x plus 5 equals x squared plus x. And since I have the squared here, I'm going to want to solve this to 0, and then I'm going to want to factor it out because I can't easily solve for x right now. So I'm going to get this solved for 0, so minus 5x to both sides would give us I'm going to write it over here because I'm running out of room. X squared, x minus 5x gives me negative 4x, and then equal to 5. I still need to get that 5 on the other side because I'm trying to set it equal to 0. And that would just be x squared minus 4x minus 5 equals 0. And now if I factor that out, that's going to give me my possibilities. If you recall from factoring, we need to multiply the outside numbers. So the coefficient there is 1, so 1 times negative 5 is negative 5. And then we're looking for factors of negative 5, and the only factors of negative 5 are 5 and negative 1, or negative 5 and 1. So we're looking for factors of those that are going to add up to negative 4. So I'm looking at that, and I could do negative 1 plus 5, but that's going to give me a positive 4. Or I could do negative 5 plus 1, and that gives me a negative 4. So I definitely want to choose that second option. So negative 5 and 1. And then I always write that over my lead coefficient, which is 1. And that 1 just tells me the coefficient of my variable when I put them in the factors. So it's going to look like this. That 1 again was my coefficient for the variable, so that would be 1x, or just x. And then that negative 5 goes right here. That's a minus 5. And again, that bottom number is my coefficient of the variable, so that's x, or 1x. And then since that's a positive 1 there, that's plus 1. And now all I need to do is set these equal to 0. And when I do that, I have x minus 5 equals 0 and x plus 1 equal to 0, so I'll just add 5 to solve for x. And that's going to be x equals 5. And I can also subtract 1 over here, and that's going to give us x equals negative 1. So 5 and negative 1 are my two solutions. But look back at the question. This is where critical reading takes in. It says positive. So if I plug that negative 1 in for x, I'm not getting a positive number, so negative 1 is not going to be a good solution for this. So I only have one solution, and that's going to be 5. Now be careful, the question says which is the smallest. Let's make sure that we're doing that right. 5, the smallest is going to be x, so all we do is plug in 5 for x, so that is going to be our final answer, which is 5. However, if it said the largest would have been 7, and the middle number would have been 6. So just make sure that you're answering what the question is asking.